Friends, your physics teacher Mukesh sir is here with you, and today this is your physics video, physics session, and the second chapter, that is force and laws of motion. And today in this chapter I am going to explain you the Newton's first law of motion. Newton's first law of motion. This we will learn today. Newton's first law of motion, it is given here. Okay, and this law also known as the law of inertia. This law also known as the law of inertia. And I told you that what is inertia. Inertia, the definition of the inertia already I explained. Here it is given. Inertia can be defined as the property of matter by virtue of which it opposes any change in its state of rest or of uniform motion along a straight line. Okay. Also, it is a tendency of an object. The inertia, what is inertia? Inertia is the tendency of an object, okay, which keep the object in the position in which the object is. So, the inertia, and also the inertia, already I explained, types of inertia of rest, inertia of motion, inertia of direction. Okay, and these in the previous video you can watch what inertia of rest, what inertia of motion, and what is the inertia of direction. Okay, examples also, some examples are given here. You can see a passenger standing in a bus leans backward when the bus starts all of a sudden. And the second one, fruits fall down when the branches of a tree are shaken. And the third one is dust particles on a carpet falls when we beat the carpet with a stick. Okay, so all these applications of law of inertia or inertia I explained. Example of inertia of motion also are given here, you can see. So today we will learn this Newton's first law of motion. Already I said that it is known as the law of inertia also. So what is the Newton's first law of motion? Here it has been explained. For first of all, you see, we shall now study about the abstract relation between the force applied and the motion of the object on which the force is applied. This was studied by Sir Isaac Newton. He gave the three basic laws of motion, okay, concerning objects in motion. Sir Isaac Newton formulated Galileo observation into a law. This law is known as Newton's first law of motion. Newton's first law of motion. Okay, this law is known as. So what is the first law? A body continue to be in state of rest. A body continue to be in the state of rest, okay, or of uniform motion along a straight line unless an external force acts upon it. So what this law actually is saying, what is according to this law? This law is saying if an object is in motion, then it wants to be in motion. And if an object is in rest, then this object will be in rest until and unless no external force will act on the object. Till then the object will be in rest. Okay, so this is the law of inertia, and in this one the inertia of rest and inertia of motion is working here. Okay, so this is the first law of motion. Okay, this means that every object has a tendency to resist. What is the meaning of this law actually? Every object has a tendency. Either the object will be in rest or the object will be in motion, and both type of object has a tendency, okay, rest, any change in its state of rest or motion which oppose a tendency which oppose the change of the position of the object. This tendency is inertia. This law is also known as law of inertia. I told you that this law is known as the law of inertia. Newton's first law of motion gives a qualitative definition of force. Okay, it is giving the qualitative definition of force also. If on the object there is no force, if no force is acting on the object, then the object will be continue in the same position in which the object. Is that clear? So this is the law of inertia of motion, Newton's first law of motion. And next, momentum. Next topic I am going to explain, and that is momentum. So what is a momentum? A cricket ball, here some example you can see, a cricket ball and a tennis ball are moving with constant velocity. With constant velocity. A cricket ball and a tennis ball. It is, tennis ball is different. Cricket ball and a tennis ball. Both are moving with the same velocity v. With the same velocity v, they are moving. You have to apply more force to stop the cricket ball than you have to apply to stop to tennis ball. Now, if you want to stop these balls, suppose all these both balls are moving or coming to you with a very high speed, then we will apply to stop the cricket ball more force in comparison of tennis ball. This is tennis ball, and this is cricket ball. So whatever force we will apply on cricket ball, suppose force on the cricket ball is capital F and this is small f. So what will be the condition? The capital F will be the greater than smaller f. Means the force we are going to apply on the cricket ball to stop this is more than the force applied to stop our tennis ball. And why it is? Why it is? So this is the main thing why it is. Because students, this is because of the mass. A cricket ball, mass of the cricket ball is more than the mass of the tennis ball. Suppose the capital M is cricket ball and the small m is tennis ball. So mass of the cricket ball is more than the tennis ball. So we have to use more force, or we have to apply more force to apply the cricket ball in comparison of tennis ball. Okay, so let us see here. Apply to tennis ball, since the mass of the cricket ball is more than the tennis ball. Okay, that's why. Next one, the force required to stop a moving object depend on the mass of the body. This force will depend on the mass of the body. If I'm saying if, it means there is a difference. If the velocity of both the bodies is same. Suppose two different bodies are there and the mass of their bodies also different, but the one condition is there, that is the speed of the bodies should be constant or same. Then we will apply more force, okay, to stop a maximum mass object. Is that clear? So here now you can see the force required to stop a moving body is directly proportional to its velocity. Next one is the velocity, directly proportional to the velocity. Why it is? I am going to explain you. Suppose the mass of the cricket ball is capital M and the mass of the tennis ball is small m. Okay. And the velocity of the cricket ball is u, and the velocity of tennis ball is v. Here mass is different, and the velocity, here you can see the velocity of the tennis ball is more than the velocity of the cricket ball. अगर इसकी velocity cricket ball से ज़्यादा है, speed of the tennis ball is more than the speed of a cricket ball, then we have to apply more force on this ball, on tennis ball. Okay. So this is saying that the force required to stop a moving body is directly proportional to its velocity. Force, whatever we apply on the body, it is directly proportional to the velocity. How it will, let us see. Suppose this is a ball. I am going to explain it with the diagram. Suppose this is a ball and it is coming with 40 kilometer per hour speed. It is coming with 40 kilometer per hour speed. Okay, you want to stop this ball and the speed, suddenly the speed has increased 50 kilometer per hour. then the momentum of the body will increase, because the definition of the momentum of the body is the product of the mass and the velocity of a moving object or moving body. So we have to apply more force. When the velocity will increase, we need to apply more force to stop the moving body. When the velocity of the moving body will decrease, then we need to apply less force to stop the moving object. So it is directly proportional to its velocity. Thus the quantity of motion in a body depends on the mass and velocity of the body. This quantity of motion defined a new physical quantity called momentum. This physical quantity of the object is called momentum. Okay, so the definition also we can write down. The momentum of the object is defined as the product of its mass and velocity. The product of its mass and velocity. Momentum is a vector quantity and its direction will be same as of the velocity. It is represented by a small p. The momentum, the letter to represent the momentum, that is a small p. P equals to mb, means mass into velocity, where m is the mass of the object and v is the velocity of the object. Now SI unit of momentum is kilogram meter per second. Student, kilogram meter per second, how it will be? P equals to mb. The SI unit of mass is kilogram. The SI unit of velocity is meter per second. So it will be the unit of SI unit of momentum. Okay, that is kilogram meter per second. Okay, you understood? Now this is the second law of motion. What is the second law of motion actually? This is also called the law of momentum. This is also called the law of momentum, because in this one the force is directly proportional. According to Newton's second law, force applied on the object is directly proportional to change in momentum. Okay, upon time taken or per unit time. The force applied on the body is directly proportional to change in momentum per unit time. Okay, and because here change in momentum is going on, so that's why this law also known as the law of momentum. Newton's second law of motion, also known as the law of momentum. Okay, and you have to drive this equation also. How we can drive? Suppose an object is moving with initial velocity u, and after t seconds it attains the velocity v, and the mass of the object is mm. Mass will remain same. Then what will be the force? F equals to change in momentum. F is proportional to force change in momentum, mb minus mu upon t. So this is the force, and when upside we will take m is common, then what will come? Let us see what will remain then. It will be F equals to F proportional to m is common, in bracket will remain v minus u upon t. Okay, then F proportional to m, v minus u upon t equals to, this is acceleration. The definition of acceleration is change in velocity per unit time. So in place of this we will use a. Then F is proportional to ma remain. Then next then we will remove the proportional sign. There will be constant will come a. Take k equals to 1 unit. Then F equals to ma. F equals to ma. And hence this is the derivation of Newton's second law of motion. Okay, here it is given. You can see this change, or everything is written here, and you can see. So this is the Newton's second law of motion, and also this law is known as the law of momentum. Up to here you can see force equals to mass into acceleration. The negative sign indicate that the gun is recoil, and whenever the force will negative, then that is called recoil. Okay, recoil force F equals to ma. SI unit of force, you know, the Newton. SI unit of mass is kilogram and acceleration is meter per second square. So the SI unit of force is kilogram meter per second square or Newton. Why it is Newton? Because this law has been given by the Sir Isaac Newton. So to honor him, it is also known as the law of motion. The SI unit also known as Newton of the force. Okay, SI unit is Newton. To honor the scientist Sir Isaac Newton. So this is your Newton's second law of motion. Up to here, you please watch this video again and again and revise it. God bless you and thank you.